Hello, and thank you for joining us for our webinar with Magswitch. I'm Nick Holt, editor at AMS. For this presentation, I'm joined by Cengiz Kizilkan. He's President, Global Sales Automation and the Executive Director for Europe for Magswitch. Cengiz has been working with Magswitch since 2012 and established the European subsidiary in 2013. He started his career as a proposal engineer and gathered a lot of experience in the area of body and white manufacturing. And he has over 20 years experience in the industry. So today we're going to look around technology in the body shop, and whilst the body shop has traditionally been one of the most advanced in terms of automation, new trends in the automotive market such as shorter product life cycles, the demand for more customization, need for flexibility in the production line, and obviously the transition to electric vehicles is demanding more innovation in the process technology. So today, Cengiz will discuss the drivers and challenges in adapting to flexible and modular manufacturing, and also offer as an exclusive world premiere of the new Magswitch surface adapting technology. I had a sneak peek of this, and it's really interesting stuff. Before we begin the presentation, I'd like to invite all of you to send some questions for Cengiz to pick up in the Q&A session that will follow his presentation. You can just type those questions into the box in the lower and right-hand side of your screen. If you experience any technical issues, you can let our team here know using the same chat box. Right, without further ado, I'm going to hand over to Cengiz to begin his presentation.
Thank you, Nick, for the intro, and welcome to everybody to this webinar. And I would like to start with transferring the screen. Short feedback if it's the correct one. Okay, so welcome to the webinar talking about really innovative solutions for body in white. And as Nick already talked about challenges, this is also where we want to start, and that's also why we come up with all these really innovative solutions and the relative enablers. Challenges of body in white starts really from the end users. Everyone who is purchasing a car is interested in a variety of options, individual design, nice design, etc., etc. And the latest eco-friendliness, short delivery times are also added to these requirements. This is driving the OEM development, with increased quantity of models, then cost reduction by carryover parts, light and robust structures using more robust materials on one side and lighter materials on the other. This again are driving solutions and requirements for the manufacturing side of it. High flexible production facilities become mandatory. Use of new materials, joining technologies, resulting in really heavy tooling. Space restrictions, we are talking about brownfields mainly, so existing facilities. And limited budgets are always a constraint, and the lowest life cycle costs are aimed since ever. Let's see if this is also really coming, and as we can see here, the quantity of new models with their start of production per year over the past 11 years show already how this is developed. If we are putting in the trend line, it definitely is an increase of quantities of cars built, and also the need of new solutions in order to accommodate the higher quantity of models. Summary of that is that all OEMs are focused on energy savings, and in some cases based on the energy management certifications, ISO 50001. In others, with the simple goal of reduced manufacturing costs. KPIs are mainly really based on reduced fuel consumption, nowadays also together with the reduction of the CO2 footprint. Usage of high-strength steel, each kind of variation is driving joining technology, and that's also the diversity of the models are also driving the use of platform strategies and carryover parts to reduce the development costs from the OEM side. Now the big question is, what if you could really reduce the capital investment in body in white lines by at least 20%? What if you could increase the flexibility of your body in white manufacturing lines with no additional space requirements? What if you could reduce the footprint and the space for your body in white lines at least by 10%? Same also with reduction of a significant reduction of labor in producing cars. As said before, what if you could really reduce energy consumption and the carbon footprint significantly by up to 90% actually? And also utilizing the Magswitch method to shorten project delivery by up to 25%. And the answer to that, our answer to that is applying the Magswitch method as the solution. This will give you lower capital costs and lower costs to operate, at a higher flexibility of the manufacturing lines, utilizing a smaller and lower footprint with less labor to run the lines, reduce energy consumption, and again, shorter delivery times. All this starts already with the project organization. Traditional waterfall project approach is displayed here. At the very beginning, there is the section. There are three core sections. The first one is the process planning section, where the project timing, the requirements are set. Process initially is designed, concepts are put together for the manufacturing lines, draft layouts are put together, following the joining sequence and incorporating the necessary joining technologies to assemble the body in white. In the next major block, there's coming the mechanical engineering portion of the entire project, considering joining technologies, sequence of operations, then CAD is involved, operator counts, optimizations, then media, how much compressed air is necessary, electricity, even hydraulics and pneumatics, and of course detailing of a layout. And we are starting here in this stage already with the offline programming, step 1 and step 2. The last block is controls engineering, and then finally really the installation on site. Controls engineering is adapting on mechanical engineering. So these are flows which have to follow each other, which is clear. Yeah? But what if we would really go in and try it with an agile project approach? With the core components consisting of teams driving innovation, including the end user, specialists from automation side, controls engineering, mechanical engineering, and simulation, as well as planning, who are building together a core team. Depending on the progress of this project, we would be involving specialists and also core technologies like special joining technologies, laser welding, laser brazing, hemming, etc. With this one, we will really ensure that there is a constant flow of information following an agile approach throughout the entire project phase, considering the know-how and the feedback from the automation guys, which are really coming towards the end of the project cycle on site, and considering their input already in the very early planning phase. So this kind of approach we are pushing, and we have applied in previous programs, which we will be presented to you in a short while. The Magswitch method. We from Magswitch believe in being involved in the very early stage of a project, from simultaneous engineering over process optimization through the Magswitch finite element method, over process simulation, the integration support on site will lead and has led in the past programs we have been able to support with reduced capital investment and reduction of operational costs. In the next two slides, there will be really hard figures. We are going to present you here from the first large-scale programs we have been able and happy to really participate. Please keep in mind that, of course, the real values we are not able to share, but as you will see here, we are putting this in percentage. So let's start here. The conventional method on quantity of EOATs for this first larger scale project execution program were 382 EOATs, meaning end of arm tools, which are the grippers at the end of a robot who are actually handling parts, etc. We were able to reduce by our involvement using Magswitch technology and our skill set to reduce this from 382 quantity to 347, which is a reduction of 9.16%. Having said that, we also, because the multi-purpose usage of our tools enables us to eliminate docking systems, we're able to reduce the quantity of docking systems, which are used to exchange on one robot from one EOAT to another one, from quantity 318 to 231, which is equal to a reduction of 27.36%. Looking at the average costs per EOAT, even though the quantity has already reduced, we were also able to reduce the amount spent by EOAT in average by 14.3%. Summarizing all this up in the first project execution, limited to really basic EOATs with highest priority of eliminating docking systems, EOATs, and even robots, we were able to contribute to savings of 13%. With this success story, we have been awarded with the second larger scale program, which has been executed already, where we were able to contribute in total, based on the same input from us, based on our early involvement, to reduce the capital investment by 22.7% on EOATs. Again, the quantity of EOATs dropped from 405 to 351, and a dramatical reduction of docking systems from the conventional planned body shop from 324 down to 190. This is possible because we are making everything smaller. We are able to accommodate an end of arm tool with a weld gun in combination with gripping technology, which is making any kind of docking obsolete, saving cycle time. Let's look how we did this and how we achieved it. In the past years, we have developed specifically for thin material handling purpose products like our D series. In general, we are separating between pneumatic operated, electric operated, manual operated tools with and without intelligent sensing. The T series, the D series are simple on-off magnets, 100% on, 100% off, very reliable in their functionality. The J series, also pneumatic actuated, comes with intelligence where we are able to deliver, beside the clamping force and hold force, also part presence and double blank detection. The AR series, very similar to T and D series, is a stronger magnet which is utilized quantities of several hundreds body shops with the ability of adopting pole shoe technology, which will be explained in the next slide. Our brand new E-Series is now going away from compressed air actuation towards electric actuation. The main advantage of it, beside the same intelligence like at this J-Series, part presence and double blank, is that we can define the strengths and the depth of our magnetic field. With this, we are able now to destack parts 100% process safe. Means we are adapting the hold force and the depth of the magnetic field to the needs of the part and are able to unload and destack 100% a single part and check if we have a single part on it without any external sensors. The sheet fanning device is also used partially in body in white because in some cases, due to very thin and very long objects, the operators by unloading and loading might have a problem by separating them, and from time to time they are loading two parts instead of one, where the sheet fanner is now guaranteeing a separation of the parts. I mentioned before the pole shoe technology. Pole shoe technology allows us to adapt to any shape of the target which we are going to take from a deposit, from a nest, from a stand, from a station, and transport it to the next one. This is unique patent pending technology, which is supporting us to apply the highest holding force on thin material like used in body in white, starting from 0.5 millimeters up to 2.5 millimeters. The same functionality of the basic tool is also used to convert the Magswitch into a pin clamp, a magnetic pin clamp. Two-way or four-way pins are able to be adapted to a special set of pole shoes and allowing accurate positioning and anti-rotation feature of the EOAT to the part. Having said that, one of the main reasons of using docking systems on robots, where we are talking about flexibility, is the different shape of the parts. Different shape of the parts is driving the use of docking systems on one side. With the use of single-sided clamping technology from Magswitch, we are able to accommodate certain features using pole shoes to use one tool for multi-purpose because of the different working phases of our tools. In some cases, this is not enough to avoid any kind of docking systems, especially also in bin picking, which is now more and more coming. We are facing situations where we need to use pole shoes tailor-made for a particular part, with the result that we have to change the tool for different parts. The next slide, I would like, really proud to introduce you surface adapting clamping technology as a world premiere here from Magswitch for handling parts by adapting to any surface by using this now patent pending technology, which is applying the magnetic force through these pins, adapting to the surface and transferring the part from A to B. This is not only a really neat solution for single applications like we see here, bin picking or so. In the next generation, it will also help to be used on EOATs, which will allow us to completely eliminate docking systems at all, independently if multiple parts from one model are handled, or if different models are used in one manufacturing line. Yeah, a couple of close-ups where you can see that it is really adapting to any kind of surface. The true holding force is applied to the part. Destacking is not a problem with our Cobot E30 tool on this display, where we can not only handle the tool but also adjust it, so we can make sure that we are destacking each geometry different part, and also making sure that only one part is detected. So this, we see here a really big enabler in the future body in white applications. Let's look into case studies. We have been carried out, again, due to NDA reasons, we are not able to share with you the real layouts, but everything what you will see here on schematic layouts is based on real layouts. The bombs and the premises, which you will see, are also here. The requirements for this first study we have carried out utilizing the Magswitch method. You see here the original concept, cycle time of 51 seconds, flexibility of 4 models. Each robot with an H is a handling robot with an EOAT on it. The turntables beside each handling robot are used for unloading the gripper EOAT for model A and loading the gripper EOAT for model B, C, and D. So it's a 4-phase turntable. The model change is done here in this case in batch. Compared to this original concept, we were able to develop this alternative layout. As you can see, and you will see it on the next slide, in a direct comparison, it looks already way less on equipment, fulfilling the exact same requirements with 51 seconds and 4 models flexibility, where the 4 models are completely different. Hood is typically one of the outer parts which are impacted by any kind of design change. The summary of this first study, which we carried out, is a direct comparison of the original schematic layout versus the Magswitch method layout. You see here, we have been able to reduce original equipment significantly with providing really significant savings, which are way more than the 20%. A second study was carried out also for hang-on parts, in this case the door reassembly lines, right-hand side and left-hand side, with a cycle time of 86 seconds with a flexibility of 2 models, and in this particular program the model change was within the cycle time. Also in this case we were able to adopt the Magswitch method and utilize our enablers to come up with this alternative concept with again pretty significant reduction in hardware. As you can see, the robots have been reduced from 44 to 30, sorry, saving 14 robots. Again, the footprint, and this scale is the same, reduces significantly. The quantity of equipment reduces. The quantity of safety zones, which have always buffers in between, is reducing. Because of the less equipment, the availability goes up. At the end of the day, the output is higher at same high cycle time. The Magswitch method, what does it? How is it achieving what we are talking about? Here's an example of a small part handling. The clamping method, conventional, you see on the left-hand side, is typically used to center the part, to clamp the part, to position the part, to drop it to a fixture. You have to hold it in position until the fixture closes. Therefore, a lot of kinematics and movement, swinging in clamp arms, going back and forth, linear cylinders are used in order to make it happen. In comparison to that, this is how the clamping of a small part would look like using a Magswitch. I think you all will agree that this is absolutely not comparable. The GEO fixture floor half, I called it, in comparison to each other. On the left-hand side, you see a GEO fixture in a traditional way, which also allows the use of a GEO end-of arm tool conventionally. We'll see it on the next slide. And this is how the same functionality fixture looks like using the Magswitch method. Also here, you can see we do not have any kinematics going on the fixture side. Whereas over here, we have quite a bit of clamping going on, slides, and also sequence of operations in order to really clamp all the parts in cycle. This is how the entire fixture looks like. And you have to say and agree that the robot path is coming in here, setting GEO spots. So resistance spot welding in a GEO fixture, setting the geometry here, is way longer and takes much longer because the robot has to bypass all hardware here on clamping in order to go in with the weld gun and set the spot. Over here, this is very short, the distance from spot to spot. The OAT design also helps you not only save money, of course, but also significant reduction in weight. This is a real executed study. This was the original conventional gripper from production. We have been given this EOAT as a spare EOAT, asked to use our tools in order to test our tools. By utilizing our tools on this EOAT, following exactly the same processes which were run in the live production, we were able to reduce the investment of this EOAT only by 5.3%. But a pretty significant reduction in weight was achieved with 27%. Based on this successful implementation, which led also to almost 5 seconds savings in cycle time, we have been asked to design an ideal EOAT, which ended up being 21.4% cheaper in purchasing and 36% lighter in weight than the original one. Besides the capital investment, we also contribute a lot to the reduction of running costs because we are using less or none compressed air. Depending on the strategy and the wish of the customer, utilize either pneumatic tools, which are actuated using a burst of air, or 24-volt electric tools. Why is this GEO concept in the Magswitch method so different than others? We are using 3 50mm tools, electric actuated in this particular case, not only to locate with 2- and 4-way pins, but also to clamp the EOAT against the fixture. This is applying a hold force of 2.5 kilonewton per tool plus the weight of the EOAT, which is totaling up to approximately 1,000 kilo force applied to hold the EOAT against the fixture. If you are now dividing this by the supports here, you will be ending up at the same clamp force by clamping point like on the conventional method. As already described before, it's not only helping to reduce weight, it is also reducing cycle time. As already indicated, the robot path is quite a bit reduced. Here on the left, you see the Magswitch Method GEO end of arm tool docked on the fixture. Both robots start in this simulation at the same time, and the left side already is advanced because he doesn't need to go out completely out of the periphery like this robot on this side to go around the body of the power clamp, go in and set its spot. So all this contributes to the fact that we are able to place more spots in one station than using conventional methods. Besides the reduction in robot movement, we are also contributing to saving productive time of any cycle with the high actuation times. Within half a second, our tools are clamped and unclamped, taking or releasing parts. In conventional clamping, it can, depending on the arm length of the clamp, can take up to 2 seconds. If you are considering in geostations certain sequences of clamping, putting in clamp, then the part, then the next clamp, this is totaling up pretty significantly. In our case, we are able to utilize more time effectively and reduce non-value added time, which in this case are robot movements without any value you are adding to the process. Let's look into the technology and skills pyramid. We have defined this based on really the component level, standalone systems, commodity solutions, and the entire body-in-white process solution. On one side, on the hardware side, on the skill side, we are looking at mechanical software for product engineering, the mechanical and software engineering for delivering standalone systems, the specialized process engineering, enabling the integrators to really create commodities. And the full-size body shop is requiring the high-level process design. The higher pyramid levels are always assembled with a larger percentage of the smaller ones. Let's go into the single components. So on the component level, the lowest level of this technology pyramid, we have components like single power clamps, shift pins, suction cups, Magswitch, vision system, docking systems, etc. These are assembled into EOATs, geo-fixtures, conveyor systems, which are building the second stage here, standalone systems. A combination of those are leading to commodity solutions. A body-in-white mainline, underbody subassembly, so-called robot garden. Multiple commodities, of course, are leading to the full-size body-in-white process solution, which is considering the entire manufacturing of body-in-white, following certain process flows. At Magswitch, we are contributing to the entire body-in-white process with our great technologies, with our products. On the skill side, beside, of course, all the skills we have to come up with these great products and solutions, we do have in-house capabilities of specialized process engineering and the high-level process engineering to come up with solutions for the entire body-in-white. This was already carried out and presented in a white paper back in 2013, where we said, by using Magswitch technology in this executive summary, this white paper is also available on our website through link on AMS, we are able to reduce non-value-added times by up to 35%. We are able to contribute to reduction of investment to 27%, which by now really is proven. Running expenses for compressed air are reduced by up to 89%, which again is also proven. The reduction of lead time means how long it takes until I finish a car. We are contributing with a saving of up to 14 minutes. This, a little bit of further explanation, is because we don't need so much stations, so many cycles to complete a process. We are able to combine, because of the Magswitch method, several geo steps in one. We are able to eliminate stations which are equal to cycle, which is resulting in a faster throughput of the line. And as showed in the studies, and again, these are real studies we have carried out, including reachability analysis in 3D, robot simulation, etc., etc. We are able to help reducing the footprint of a manufacturing line by up to 25%. The additional benefits back in 2013 were, of course, smaller size EOATs, as we don't need to clamp and position the clamping tools outside of the part line. The weight reduction as shown, the reduction of tool changer, faster spot-to-spot times, savings on energy, on engineering, I'm sorry, savings on engineering, because we are just designing one side, no kinematics. We don't need to consider in the accessibility studies, in the robot simulations, any kind of open and closed condition of anything. On Magswitch-GEO ATs, there is no kinematics. What you see on CAD is what you get on the site. And because we are using less equipment in general, the buffer quantities and they are reduced, because the availability of the line, the technical availability of any line manufacturing wise is higher. This is leading to less buffers. And these were theoretical outcomes of a study we have carried out over multiple car manufacturers' models with average numbers at 60 JPH and 47 JPH cycle times. And during the past 7 years since the white paper was set up, we have been able, one by one, to take any of these theoretical values we have announced back in the day, now with real-time hardware, and we will continue in contributing with our solutions and also with our really excellence in understanding processes and the needs of our customers in body-in-white manufacturing, and deliver the appropriate solutions for the next generation of body shop. Having said that, I would like to thank you for your attention. It took me 40 minutes, and I could speak 3 days, and I'm more than welcome to be available for any kind of question and answers in the next 20 minutes. Thank you very much.
Thanks, Cengiz. Great presentation. I know I had a sneak peek of this the other day, and fascinating technology and a really good insight into the way that body in white's been operating and some of the challenges coming up. we do have some questions for you. As you said, we could probably speak for a very long time on this particular topic. I just wanted to bring up with you a couple of things. We're looking at a sort of shift in vehicle architectures now. I know one of the key things that you've been sort of stressing around your solution and the challenges around body in white has been flexibility, the need for flexibility. But in your experience now, we're seeing this shift towards electrification, and on the outside, vehicle architectures don't look that different to the outside, but internally, obviously, they are being changed and optimized for batteries, electric motors. Is that seeing greater pressure on body shops? Is that seeing the requirement for the system that you're now providing coming to the fore? Is that putting more pressure on them in terms of the challenges? Obviously, they're sometimes trying to run multiple vehicle types down a single line, which has always been quite challenging anyway. Do you see this? Sorry, Karen.
You're absolutely right, Nick. The introduction of more and more electric vehicles, ideally in existing lines, is a challenge, because we are talking about different joining technologies. We are talking about different implementation of parts in different sequences of the manufacturing process. So this is definitely a big challenge for body in white. And right now, it is really not being addressed. It is the trend that all the electric vehicles are not built on the same cars, on the same existing lines of conventional consumption engine vehicles, but in new lines in majority of the cases. Besides this, there's also coming the complexity of joining technology, which is required somehow, because different material composites are used, different strengths of material are used, riveting and clinching. These kind of processes are added, and they are not really good in conjunction with spot welding, for example. Yeah, spot welding, you need a weld gun, and that's it. And with riveting, you need different equipment. You have, depending on the location where you are putting this in, different requirements and space constraints. So this is something which is adding complexity to the entire thing. Therefore, our aim is really also to contribute to the reduction of floor space and have an impact on a positive impact on intralogistics within the company, that on the line side, there is sufficient space now that additional equipment on feeding systems, etc., can be accommodated.
I've got some questions coming in from the audience here, Cengiz. So question here is, how does Magswitch ensure the part geometry? I mean, you mentioned their use of pins and magnetic foot plates and shoes. I think the question is here, how do you kind of ensure that geometry is maintained?
Okay, so in principle, we are following the JD&T or the clamping plan, which is provided by any OEM. Yeah? So it can be still fixed pins, shift pins, in addition to our tools. But what we are trying to do successfully, have done in the large-scale projects, which I mentioned before, is with the high really strongness of our tools, the high attraction force and the holding force of our tools, we are able to support safety factors of greater than 16:1. So 1 kg of part weight requires at least 16 kg of hold force. And with multiple tools, anti-rotation features, either mounted on the pole shoes or really using the pin locators, which are given by the part and the JD&T, we are following 100% what the JD&T is asking for.
Question here. Is it the single side clamping which gives the process, the technology, greater flexibility?
Okay, so the single-sided process, we call it kissing and not hugging, is really contributing a lot. You have to consider that you need really extraordinary hold force in order to not use or being forced to use safety features like additional safety clamps, which are there just to, in case we are losing the part. So we are the only really manufacturer of single-sided clamping technology which is allowed on OEM side to be used after our input in terms of simultaneous engineering, in terms of pole shoe design, in terms of Mag FEM carried out by us, delivered in a report. Yes, this application, this EOAT on this particular part is safe. So this is coming from us. And with this, you are able to reduce really a lot of weight, which is contributing to faster movements, to things you cannot do really with traditional clamping because of the size of the EOAT. We have built, and they are in production, roof EOATs for really large vehicles, 2 meter by 1.5 meter roof panel, Class A surface, and there are no safety clamps at all. So this is contributing a lot to the benefits of single-sided clamping technology, which you have been introduced the last 45 minutes.
Yeah. Another question. Sorry, did you sorry, finish? Sorry.
I think it was a really great question.
Question here regarding, is the technology Magswitch Method applicable to non-ferrous materials? Obviously, I think you mentioned there we're seeing a lot of different materials being brought into the body structures now.
Yeah. So of course we are not able to clamp and handle non-ferrous materials at the moment purely with our technology. Having said that, the geodocking system, which can be used on really multiple locations, is able to be used. Why? Because we are clamping through the aluminum panel, for example, against a steel plate, and pinching or clamping the panel like we are doing it, like a power clamp does. Yeah. So there's no magnetic attraction to the part itself, but we are mechanically clamping the part in position using a steel target on the opposite side.
Okay. There's a question here. Now, I'm not an expert here, Cengiz, so I might not have interpreted this correct. But the question is there a possible axes of gripping or clamping? So I'm not quite sure if that. Apologies. Is it possible to adjust XYZ? And I think again that must be around the clamping axes.
Yeah. So typically on EOATs and also on fixtures, you're using adjustability in XYZ. L brackets on L bracket, which are using shims packages to really fine tune that stuff. It's exactly the same. You can do. We have repeatable mountings on all our tools. NAMS is one standard we're using, and we are not relying on ball mounts like others. We have really repeatable mounting with 2 pins and at least 1 bolt in order to secure and make the adjustability possible.
Question here. I mean, you may have touched upon it a little bit about with the non-ferrous materials, but what are the limitations of the Magswitch method?
Handling with only Magswitch tools, non-ferrous materials.
Yeah.
Really the only thing, right? Clamping on a fixture is possible, but pure handling is, of course, not yet invented. We are working on something which will allow that.
Okay, that's something in obviously, because obviously that's another challenge that's coming forward. Is that something you're developing your technology around that?
Yes, absolutely. So we have been really asked by executives from OEM to look also into future materials which might be used in 5 to 10 years from now in body in white manufacturing, which are definitely non-ferrous. And we have started already since we were faced with this almost now a year ago with the development of several products which are relying on the various features of target part.
Okay, and can you reveal if there's a timeline with that, Cengiz? Have you got? Are you ready to announce that in the next anytime soon, or?
Definitely this year.
Definitely this year. Okay, so we'll look out for that then. Yeah. Question here regarding performance of holding force with the Magswitch. Does that reduce over a period of time? I'm assuming like lifespan of the tool itself.
Yeah. Also, again, a good question. And yes is the answer. Approximately 2% reduction in hold force in a couple of million of years. So essentially, the answer is really no, because we are not within the lifespan of 1, 2, or 3 programs. Yeah. If there's not a really hard impact, which is destroying the magnet itself, it is not losing any hold force.
Yeah. I mean, you as part of the presentation, you're discussing the way you're minimizing the number of EOATs and flexibility involved in that. A question here is kind of, obviously you're developing the technology as you go. You demonstrated different layouts comparing it. What do you see as the next steps in flexibility in EOATs? Do you see it, or where's it sort of the technology going in that respect?
I mean, there are multiple ways of looking at it. Yeah. First of all, live with what you get. Yeah, meaning the product you are getting. So this is what we are facing at the moment. Having really multiple conversations with different development partners or development departments of body in white structures. You are facing a very hard wall of flexibility. Yeah, requiring, for example, certain common clamping points, flat areas, which would support perfectly the multiple use and standardization of EOATs, single-sided clamping, are always turned down. So it would be great if we could get a little bit of understanding and a little bit of help from the part development side, allowing and listening to the manufacturing and saying, okay, good. I mean, having a flat surface in this area is really not a problem. In that area as well. So we need 3 points which are defining one plane, and you are done. Yeah. Ideally, these are on the same side. That's it. But we are also now working on the next generation of really flexible EOAT. And this is no longer looking at part geometry, it's looking at the part volume. Anything which is within a certain volume, XYZ, we can handle with the development we are now almost done with. So this is also something we are going to release this year. And this will be a really high flexible EOAT solution where you need to design one, you need to purchase one standard product and accommodate, let's say, at least 40 to 60% of all parts in body in white, independently which model, which type. This is now something cooking in our R&D center.
Yeah, that'd be really interesting to see. I'm sure we'll get a lot of interest in that. In terms of the process planning of body shops, I mean, from experience, they're a bit like paint shops in a way. They are kind of, they have been a very very fixed approach to the way that they work. They're a high capital investment proposition for any tier supplier or OEM. When would be the kind of best time? You mentioned, sorry, going back, you mentioned some retrofitting as well that you looked into, or you showed some analysis on. When was the best time or the ideal time to involve Magswitch in the process planning of the body shop?
As early as possible is the answer to this question. Ideally, prior to simultaneous engineering, we should be really involved in order to gain the most benefits. It is clear that we have faced it so many times. The custom end user finally decided, okay, let's look into Magswitch. Yeah, we have seen here the studies being carried out, etc. And then you are going into the meeting and saying, oh, this is too late. No, the design is already really very progressed, so we can not do this kind of changes, even though there would be significant savings and advantages, any kind, but it's too late. So we have faced this situation really a couple of times. In order to gain the biggest and highest benefit, it should be the case that we should definitely be involved prior the body shop is awarded to any integrator to be built. Yeah, so very early stage. That in some cases we still have the chance to really also have influence and provide feedback to part development. Minor changes, but which have significant effects on body-in-white.
And that's a really interesting aspect at looking at the part design. And so I mean, we look at manufacturability in many ways from kind of the initial concept right the way through. But when you're getting down to that point of the part design for efficiency in body shop and further on, that's really interesting. We've got time just for another couple of questions. Just to let the audience know that any questions we don't get a chance to put to Cengiz now, all of the questions will be passed back to the Magswitch team, and they'll be able to respond accordingly, probably in a little more depth if you need to after the session's over. And the question here, can they view the webinar afterwards? Yes, you can. We're being recorded and it will be available on the AMS website in due course in the voice section of the website. Quick last one of the questions here, Cengiz, going a little bit back to what we said about the performance of the equipment over a longer term. Is there any loss of magnetic force due to welding? Obviously, the proximity of the welding systems and the heat generated.
The heat generation is a concern, but we have to differentiate. In body-in-white arc welding, for metal arc gas welding is not done so often. Yeah. For spot welding purposes, there is absolutely no constraints. There have been done really a lot of studies, a lot of tests prior allowing us to enter really sites. And there have been done tests where the unit was in between, within the gun arm of a medium frequency gun, which is in the case of setting a spot, providing a really big electromagnetic field, which had zero impact on any holding force of our tool, and also the tool, our tool, with the magnetic impact on the part it is applying, had no impact on the weld spot quality, which is also a very significant point. So up to 20 mil beside our tool, you can set a spot weld, and it will have neither impact on the tool nor an impact on the weld spot quality.
Okay. I was going to one last question for you here, Cengiz. Then we'll probably bring the session to a close. As I say, we'll pass on all the other questions to you. What are the sort of main differences in using your technology for the shop floor operations and in terms of kind of maintenance compared to the conventional clamping methods that you were mentioning earlier on and that you see across most of the body shops at the moment? What are the big differences there? Okay,
there are two main, I would like to separate this question. The first one is really the persons who are running the production. Yeah, they need to get used to it, because they don't see physically that anything is really holding the part. Yeah, it's weird. It is scary in some cases if a roof is handled without you seeing really that something is holding it. So this is something people need really to get used to it. And on the maintenance side, the answer is very simple. There is no difference. When you turn our tools off, they are off. If you want to clean them, you clean them exactly the same way like you're cleaning a power clamp. There is no difference at all on maintenance side.
I'm guessing if the EOATs are lighter and there's less complexity in there, that must be putting a lot less strain on the robot arms over time as well.
Absolutely, yeah. So longevity on one side or higher speeds on the other side.
Yeah.
Or higher utilization.
So that's, I'm going to draw the session to an end now because we're just about out of time. So thanks to our audience and for all your questions. Thanks for joining us. Cengiz, great presentation, really informative, some real good insights into challenges in the body shop, what's going on in the future, Always like to see process technology on AMS, so fantastic, really, and thank you for giving us that little premiere of the adaptive system. Really interesting to see something like that. For everyone who's watching, you can watch this again or pick up on the AMS website, and that will be able to join us for anyone who's not been able to join us for the live presentation. It's in the Voice of the Industry link on the website. Thanks again for taking part. I hope you'll join us for the next time. And I want to say thanks very much, Cengiz, and see you soon, hopefully.
Thank you, everybody, for listening in, and see you.
Bye.
Bye.